If you just joined, my name is Ian. I typically do cooking classes, but because today's experiment involves so many things that we can eat, it's very food focused, I figured I'd help out with this one. Today we're going to be talking about glaciers, which are a geological formation. They're part of the reason that our world looks the way it does today. Well, we got a lot of people coming in. Before we get too far into it, just a general reminder, we're going to use thumbs up, thumbs down. If you got a question, go like that, and I'll try to call on you. If I don't see you because I'm back there at my table, you can feel free to unmute yourself and ask your question or answer a question, as it may be. So, jumping right into it, does anyone know what a glacier is? Go for it, Sadie.
A glacier is a type of, it's like a mountain made out of ice.
Mountain made out of ice. You're getting pretty close there. It's definitely made out of ice, and a lot of times it's in a mountain type shape. Glaciers can be absolutely massive. Next, go for it. Oh, sorry, I cut you off there. Go for it.
I believe a glacier is an island. It's like an island made out of ice, and sometimes kind of just melts.
Yeah, a glacier definitely can be an island, and usually if an island is just made out of ice, it's called an iceberg. It's just kind of floating in the ocean, a big old ice cube in the ocean. But glaciers can be islands. That's quite true. They can be totally surrounded by water. Anyone else have any thoughts on what a glacier is? Go for it.
Okay.
Well, it has bedrock and some dirt and other stuff covering it, and then there's some ice.
Yeah, you got a lot of components there. So there's lots of dirt and rocks and rubble and bedrock, which is the bottom layer, the bottom rock layer. And then on top, you got a lot of ice. So you guys are all getting a lot of parts of what a glacier is. A glacier is made out of ice. Technically, it's made out of snow that's so heavy that it's been packed down, kind of like if you're making a snowball and you pack it in your hands for a really long time, and it gets really icy and hard, and maybe a little bit dangerous to throw at someone. That's what a glacier is. It's packed snow that turns into ice. And glaciers can be any size. They can be tiny, they can be the size of a car, or they can be miles and miles and miles long, just these huge pieces of ice that stretch across the landscape. And a lot of times they're sitting on top of the rock and they're full of dirt, they're full of rocks, they're full of little other chunks of ice. And a lot of times they just move very slowly over thousands of years across the landscape. Where do you guys think glaciers can be found in the world? Natalie and Emma, go for it.
I think they can be found in Antarctica or around Antarctica in the ocean beside it.
Yeah, absolutely. Antarctica is mostly made out of ice and snow. So there's a ton of glaciers on Antarctica. Where else? Anyone have any ideas? I saw some other hands up. Sadie.
And the Arctic.
And the Arctic, exactly. So we got Antarctica and the Arctic. Do you guys think glaciers are in deserts and jungles and other warm places in the world?
No way.
No way. Where are they usually? What's the temperature like where a glacier is?
Very cold and freezing.
Very cold and freezing, exactly. So I got a little map here I'm going to show you guys. This is a world map. All that pink you see is where glaciers are in the world. So you can see it's all around the edges of Antarctica. It's up here on Greenland and Finland and Sweden. And then we've got all these pink spots kind of in the middle of nowhere. And those are all places where they have very tall mountains where it gets very, very cold. So that's the reason there's so many glaciers in those areas. Glaciers take up about 10% of the Earth's surface. So that's a lot of the Earth. There are a lot of glaciers in the world. But one thing that's happening right now is as the world starts to get a little bit warmer, those glaciers are starting to melt and move around. Sometimes throughout the Earth's history, there's lots of glaciers, and we call that an ice age. That means that a lot of the world is covered in glaciers and covered in ice. So now that we have the background for glaciers, we're gonna get on to our experiment, which I'm sure you guys already know involves some pretty tasty ingredients. We've got some ice cream, we've got some wafers or cookies, we got a lot of different toppings that can go on ice cream, and we might all have slightly different ingredients for this experiment. That's totally okay. Basically what we're looking for is we want a bottom layer like our bedrock that we talked about. We want our ice cream, which is going to be like our glacier. And we want all those toppings, just random sizes, random shapes, random textures, to be like the rocks and the dirt that can be found underneath glaciers and in glaciers as they move around the landscape. So for my supplies, I've got those. I've got, for my topping, some sprinkles, just random sprinkles, different colors, different shapes. I've got some graham crackers that I've broken up into little bits. I've got some chocolate chips, normal size chocolate chips. And I've got some shredded coconut. One thing you might notice about all of these different ingredients or toppings is that they're different sizes and shapes. And that's going to help us with our experiment because we'll be able to see what happens to different sizes and shapes when the ice cream melts and moves around them. In terms of other supplies, I have a baking pan. I have a couple books just to stack my baking pan on. I've got an ice cream scoop, and that's pretty much it. This isn't a recipe that, or an experiment that requires a lot of different pieces beyond the ingredients themselves. So getting right into our experiment, I know you guys have done a couple of these before. We're gonna have to come up with a hypothesis before we start the actual experiment. What is a hypothesis?
A guess
Maybe
what will happen.
a guess about what will happen, exactly. So it's kind of like a prediction, right? Here's my second question. Is it okay for a hypothesis to be wrong? Do you need to guess exactly what is going to happen?
No.
No, exactly. Because the point of the experiment isn't to prove necessarily whether you were right all along. It's to see what will happen and to see if that guess in the beginning was accurate or if it was wrong. So if we make a hypothesis that turns out to be disproven by the experiment, that's totally okay because that's what doing experiments is for. So in the case of today, I'll walk you through the experiment, then we'll do the experiment and we'll see if our hypothesis comes true. So basically what we're going to do is take our wafers. I just have some chocolate wafers. You can use graham crackers, you can use cookie crumbs, whatever you want to use. I'm going to lay them on the bottom like my bedrock, which is the layer of rock that everything sits on. Once I have that, I'm going to just sprinkle all my toppings on top. They're going to be like boulders and gravel and bits of other little stuff that might be floating around. And we're going to put some ice cream on one end, a big pile of ice cream. We're going to tilt it a little bit so we have a bit of a hill for the ice cream to run down as it melts. And then we're going to wait and see what happens. Of course, this isn't a real life glacier. We're using ice cream instead of ice that's been packed down over thousands of years. But what we're doing here is making a model. And a lot of times a model is just a smaller version of something in real life. So it might not be the exact circumstances that allow for a glacier. It might be not be the exact same results of what a glacier does, because in real life, a glacier can carve out lakes, it can move mountains, but I don't think our pile of ice cream is going to do that today. But models are super helpful with the scientific process in helping us understand how larger things in the world work. So we do it on a small scale. Sadie, go ahead.
Can you use graham crackers?
You don't need graham crackers. So the topping examples that I had, those are totally optional. The only reason I'm using those is because I had them handy and because they're all different shapes and sizes. You don't even need 4 toppings. You can just have 1 or 2, whatever you prefer.
No, I mean like for the layout.
Oh, for the bottom, you can use graham crackers on the bottom. I'm just using these little wafers like this. Whatever you have handy, whatever you prefer. So before we get into it, let's talk about our hypothesis. When we put that ice cream on our pile of toppings, what do you think is going to happen as it starts to melt?
It's gonna start sliding down.
It's going to start sliding down. What do you think is going to start sliding down? The ice cream or all of the other toppings as well?
The ice cream, and it's gonna pick up the toppings.
Mm-hmm. So you're saying as the ice cream melts, it's going to carry everything with it. It's going to go downhill. I'd say that's a pretty good hypothesis. We'll have to see if that comes true.
You may have to touch it if it doesn't just roll or slide.
What was that?
You may have to push it if it doesn't roll or slide.
Exactly. We might have to push it because, remember, we're only doing this over about 10 minutes, and a real glacier can take thousands of years. So if we have to kind of push it to get it sliding a little bit, that's okay. Does anyone have a hypothesis that's different? Magna, go for it.
So maybe it might, once you do, it's going to leave some toppings of when it goes.
Okay, so you think as the ice cream slides down, it's gonna leave some toppings up at the top? All right, that's a good hypothesis as well. And once we're all done with the experiment, we'll have to see exactly what happens.
That's what happened with mine.
Oh, go ahead. What was that?
That's what happened with mine. Well, we did it before the class because Baka just didn't know it was going to be at this time.
I see.
We did it before.
So you're already a little experienced, and that's a good thing because with experiments, a scientist won't just do an experiment once. A lot of times, they'll run an experiment many times to see if they get the same result. That's the best way to prove your hypothesis, to see if you're able to get the result multiple times. Sadie, go ahead.
Do you put the sprinkles on the bottom, or do you put the toppings on the ice cream?
So we're going to put them on the bottom between the wafers and the ice cream. I might throw up a couple things on the top just to see what happens. But are you guys all ready to start with our experiment?
Yeah.
Awesome. Let's. Because we gotta make sure that we're giving this ice cream some time to melt. So I'm gonna start off super easy. I'm just taking all these wafers and I'm gonna put them down on the bottom. Totally necessary step because the ice cream would still slide and we could still put some ingredients in there, but I think it's nice to have a nice flat base for all of our other ingredients to go on, because then we know how things are actually moving. So there's my baking sheet with my wafers on the bottom. Pretty simple right there.
Excuse me?
Go ahead.
I have a tool belt with with tools on it, and this came with it. It has some screws and a hammer and a
Awesome. We got a lot of tools just in case. So I've got my wafers on the bottom. Next, I'm gonna take just my toppings. I'm just gonna throw them all over the place. We're not looking for anything pretty. We're just getting these ingredients down on our tray. And one thing that might happen as we're going along, this might get a little bit messy. We might lose some of our toppings off of our tray. They might fall down, and it's definitely going to get a little bit goopy when I have my ice cream melting all over the place. So what I'm going to do is make sure that I have a towel laid down just in case we get some ice cream melting all over the place. Then I'm going to take my tray, I'll bring it over so you can see. It's covered in all those different toppings, just kind of thrown on there. And you can see this kind of looks like a landscape if you use your imagination, right? You got the rock on the bottom, and then you got all these rocks, these pieces of dirt. Maybe the bigger ones can be boulders. So it's just a lot of stuff hanging out on the ground. Next, I'm going to tilt my tray. I'm using just a couple books here, and it's not a huge angle, but it's a little bit like a hill. So we're making a hill that our ice cream glacier can slide down as it melts. I've had my ice cream out for a few minutes now, so it's already a little bit melty and easy to scoop. I'm not just going to put a little bit of ice cream on here. I'm going to put a big old pile of ice cream. I'll probably do about 4 big scoops. So I'm just going to plop those right on the top. And it's already starting to melt a little bit because it's summertime and it's pretty warm out. Put a big old glob of ice cream. All right, I think that should probably do pretty well for us. And now we need to wait and see what happens. Awesome, I see some of you have those trays, that ice cream on there. What you're kind of doing right now is making the world's strangest ice cream sundae. Everything's a little bit in the wrong order here, but once it's all done and all melted, you're gonna have an interesting pile of toppings. How's everyone doing on the construction part of the experiment? See some thumbs up, awesome. I see some ice cream scooping going on. That's always an essential part of the process, getting that ice cream right on there. And remember, as it's melting, it's gonna be drippy and it's gonna be gooey. So it's not going to be the cleanest experiment. You might have a bit of a mess to clean up at the end. In nature, on Earth, do you think glaciers are always on a hill? Are they always moving downwards like this? What do you guys think?
Oh, that's good. But yeah.
Mine isn't really moving down.
It's not really moving down, and that's okay, because what happens with this process is ice cream doesn't go from solid to liquid in an instant. It might take a little bit of time for this to start melting. And it also depends on the temperature. If it was 95 degrees in your kitchen, it would be melting really quick, just like ice cream will melt outside really quickly on a hot day. But if it's air conditioned, it might take a little bit longer to slide as well. But even if that ice cream doesn't go all the way to the bottom, we could still check it out. Another thing to do if it's not sliding is we can make this hill a little bit bigger. We can raise it up. So I'm going to show you. I've got an extra book. So if it's not moving, what we can do is just make our hill more of a hill. And like someone said at the beginning, if it's not moving all the way down quite to our liking, we can just give it a little bit of a nudge with a spoon. You can just push the back a little bit. Because remember, as we're doing this experiment over about 15 minutes, we're kind of crunching the amount of time that a glacier would actually move, because a glacier usually takes thousands and thousands and thousands of years. They can move an inch a year. So if we're looking at our ice cream and we want it to move a little bit faster, we might have to give it a little bit of a nudge. So while we're waiting for this ice cream to melt, I'll talk a little bit about the way glaciers actually move. So because they've got so much pressure, because they're so heavy, they're pushing down, they're making that ice down towards the bottom. Sometimes that friction and that weight can create a tiny little bit of heat. And that heat will melt the ice, and there will be a tiny little layer of water at the bottom. And the water will act a little bit like our melted ice cream here. It'll be a little bit slippery. The heavy weight on top of that slippery bottom will help the glacier slowly move in whatever direction the ground happens to be pointing. So a glacier doesn't need to be moving down a hill like this, but gravity will always pull a glacier in a certain direction. And it's kind of skating on top of that thin layer of water. Of course, this isn't a quick process. Like I said, it can take years and years and years and years. When the Earth has an ice age, it's over tens of thousands of years. How's everyone's ice cream doing? Do we have anything melting at this point?
Mine isn't moving down, but it's like melting.
Starting to melt? If it's not moving down, you can give it a little bit of a nudge. Sometimes what it takes is for that liquidy ice cream to be underneath, just like with a real glacier, so that it can start to slide a little bit. Sadie, go for it.
Mine isn't Mine's barely melting, and it's not sliding down at all.
Barely melting, not sliding down. You might have to give it a little bit of a push. This experiment might have done a little bit better if we did it maybe outside in the sun when it melts really, really quickly. Go for it.
Okay, go ahead.
Go for it.
Mine started moving,
Yeah.
and my ice cream's starting to melt already.
But tell them the floor is actually shifted down.
The floor shifted.
Okay, awesome. So you're seeing a little bit of movement, both in the ice cream and that other stuff you put. Is that what I'm hearing?
From the weight of the glacier.
Yes.
Okay, awesome. So in that case, it seems like the hypothesis that the glacier will pull all those toppings down is working for you. But let's see how everyone else does. I'm gonna bring mine over just so we can check it out. As you can see, mine has started to drip a little bit. It's moved down about maybe an inch. And all of the toppings that I had up at the top are kind of sliding down with the ice cream as it melts. It's kind of like a snowplow, right? It's taking everything in front of it and pushing it with all that weight. It's not always that you get to do an experiment that involves ice cream. So once this is all done, you might just have to have a little taste. How's everyone else doing? Does anyone else see any movement with this ice cream coming down? Go for it. All right, I'm seeing some drips, seeing some ice cream getting pushed along. Magna, go for it. What do you got?
Mine start to move, and it's going on the third quack.
Okay, nice. Glad to hear that it's starting to move a little bit. And if yours is getting this kind of slippery texture as it starts to melt, like mine is, you can see I've got melted ice cream kind of all over the place. I'm gonna give it one little push just to see, and already I can see it's sliding really quickly as I push it. So you can give it a few pushes and just see what happens next. I'll bring it over so you can see. After I pushed it,
Excuse me.
go
Excuse me.
for it.
Well, ours just had 2 books. That's why it's different than the others.
Okay. Yeah, sometimes if you change the different aspects of an experiment, that's called changing the variables, you can get different results and it can look a little bit different as you go. So I'm going to show you mine.
Our experiment.
You can already see if I've got the back part, there's not a whole lot of toppings right there, but in the front part, I got a lot. So it's definitely started to push those forward.
It's actually connecting to the ice cream.
Uh-huh.
That's why it's just picking up all the toppings. It's picking up
Indeed.
some of the toppings, but some of them are getting left behind.
Uh-huh. Some are still getting left behind. That's definitely true. And that's when a glacier moves, it's picking up little pieces of rocks and dirt, and it's just dumping some of them in random places. Sometimes we get a mountain at the end of a glacier, and that's because it pushed so much dirt and boulders and rocks together. Sometimes we get boulders or lakes left behind just because that's what the glacier decided to drop off on its journey. Sadie, go ahead.
I kind of manually pushed mine down.
Yeah, let's see.
Sort of works.
Okay. Yeah, I can see you definitely have a lot more toppings at the bottom than you do at the top. But it might have to sit out for a little bit longer just to get melty enough to really move. Mine is super liquidy. Mine is super liquidy, and it's sliding down real fast at this rate. I'm gonna have a big mess in about 3 minutes.
And like, did you know that literally that the temperature on here is somewhat more cold than hot. It's more cold than
Yeah.
hot.
And that's another variable in our experiment. If it's warm out, it's going to change versus if it's cold. So if we did this in the middle of winter outside, we probably wouldn't see much of a difference because the ice cream wouldn't melt. It would stay frozen. So for our observation stage of this experiment, we've covered a lot. Some of you had ice cream that picked up all those toppings. Sometimes those toppings were left behind a little bit. But the general trend is that as the ice cream melts, it's pulling the stuff down. Max, I can see yours, and it looks like you got a lot of toppings down at the bottom and not a whole lot at the top. So that's a pretty good visual example of what can happen in this case. So on your little planet, your little baking sheet, where can you find the glacier at this point? Is it in the same place or has it moved? It's gone downhill, right? As it melts, it starts to move downhill, and it brings those toppings with it. So it's a model of the way glacier would work in real life. Even if it's not a real glacier, and even if our toppings aren't real rocks and dirt, it's still an example of the way that a glacier can work in the real world. As we're waiting this last few minutes just to see that ice cream get all the way to the bottom, someone tell me, how do glaciers move? What helps make them move? Go for it.
When glaciers melt, they start moving down.
Exactly. Once they start to melt, they get that little liquid down at the very bottom, gravity acts on them and they start to move. And what happens when a glacier moves? What does it bring with it?
When a glacier moves, everything on it or around it also moves.
Exactly. So a glacier is a little bit like a planet shaper, right? The glacier moves all of those different parts of the landscape around, pushes them, pulls them, drops them in random places, scrapes out areas, piles up other areas. So a glacier and an ice age with lots of glaciers moving around, doing lots of different things, can totally change a landscape and our planet in general. So before we end class, does anyone have any final observations on their pile of ice cream, their ice cream glacier? Mine has really started to slide downhill. As you can see, it's more than halfway down.
Excuse me.
Go for it.
Well, like glaciers, like they sometimes fall, and like maybe if you stick an acorn too hard into the ground, then it stuff may start cracking, and then a glacier may fall.
Mm-hmm. Yes, talking about Ice Age, the movie, where he sticks the acorn in and then it creates this whole different event. That's sometimes how world events happen. One little thing can cause an entire series of events that totally reshapes the way things work. Any last comments or thoughts or questions? I see some hands up, so you can unmute yourself and go for it.
Glaciers make cliffs and canyons and other stuff made out of rocks.
Mm-hmm. Exactly. That's the takeaway. Christine, do you have a question? Go for it.
Okay, go for it.
Mine is going down, all the way down.
Awesome. Is it bringing all those other toppings you put on there with it, or are they still kind of sticking up there at the top?
Some of it's coming down.
Some of it's coming down.
So some of it's coming down, some of it's staying. That's what mine is doing as well. As you can see, there's still some stuff up at the top. There's a couple sprinkles. You can see the red color, but most of it is pushing down.
Oh,
Get that sprinkles and lay and dump it on the sprinkles all over in this.
Sadie, go for it.
Mine was melting too much, so I had to take it down. Is that okay?
Absolutely. That's one of the risks with an experiment using ice cream, is you have to deal with the messy side effects of ice cream.
The bottom was overflowing, so.
Yeah. Slid down and starts to fall off the other end. But that's okay because you got a conclusion out of it. You had a hypothesis, you did the experiment, you're able to prove or disprove the hypothesis. So that means the ice cream can go away. You can be done with it. So that's about it for today's class. Thank you for joining me. Next week, we'll be back to normal for our last experiment. Until then, have a great week.
Thank you. Bye.
Bye-bye. I hope you enjoy some of this ice cream. Don't eat it all at once, because that's a lot of sugar. That's a lot of ice cream. But if you put it back in the freezer with all those toppings mixed into it, you can have a little bit of an ice cream sundae later on.
Bye. Thank you.
Bye-bye.